We're doing today. Hopefully y'all are doing well. So today we're going to be continuing our notes on Unit 7, so over stoichiometry. Now for this, we are going to be focused on the mole-to-mole ratio. So make sure you've got your notes, something to write with, and then you will also need a calculator and a periodic table for the notes today. All right, so make sure you've got all that, and we're going to go ahead and get started. So what is a mole-to-mole ratio? Well, essentially, when we look at a compound, we can actually see that there's a ratio of elements to that compound. So we call this ratio the mole-to-mole ratio. Why? Because essentially we're saying if we've got this many moles of this, we're going to have this many moles of that. Okay? And so let's, for example, take water. We know that water has one hydrogen bonded to an oxygen, bonded to another hydrogen. So water is H2O, right? So looking at this, for my one water molecule here, I've got this one water molecule. How many hydrogen do I have? Well, I've got 2 hydrogen. So the ratio of water to hydrogen is 1 to 2. We can rewrite that as for every 1 mole of water, that equals 2 moles of hydrogen. Okay? What about the ratio of hydrogen to oxygen? So again, we're still talking about water here, right? So looking at this, if I've got hydrogen, how many hydrogen do I have? I've got 2 hydrogen. So it is a 2 to 1 ratio. So for every 1 mole of hydrogen, 2 moles of hydrogen, that's going to equal 1 mole of oxygen. So again, we're just able to look at that substance and determine what its ratio of that substance to another substance is. Then if I'm looking at water to oxygen, I've got oxygen here. For every 1 of water, I've got 1 oxygen. So 1 mole of water equals 1 mole of oxygen. And so that's what we're looking at when we're trying to determine our mole-to-mole ratio. We're just going to be looking at those numbers and seeing how many of each substance I have for the overall molecule or in comparison to other elements in that substance. Okay, so let's take a look at this first problem here. So it says how many carbon atoms, so we're looking for carbon, are there in 16 grams of glucose? Well, what is glucose? Glucose, remember, is C6H12O6. Okay, so we're going to look at this and we're going to see, okay, well, I've got glucose here. For every 1 glucose, how many carbon do I have? Well, I've got 6 carbon. So that's going to be our mole-to-mole ratio in this problem. So let's take a look at this. Let's solve this. So first off, this is going to use stoichiometry. Guess what? We're in the stoichiometry unit, right? So I have 16.0 grams of glucose, C6H12O6. And we're trying to solve for carbon. My suggestion is always, when in doubt, moles it out. So essentially what I mean by that is anytime you've got a substance and you're looking for another substance or you're trying to convert to something else, solving from moles is going to be your best option. Okay, so now let's take a look at this. So I've got how many carbon atoms are there in 16 grams of glucose? So again, I need to moles it out. I need to go to moles. So based off of what we've already learned, to go from grams into moles, we use our molar mass, right? So I'm going to have to convert from grams of glucose, H12O6, into moles of glucose. And we're going to do that using our molar mass, okay? Now, I'm actually going to solve for my molar mass just somewhere off to the side. So I'm going to do it over here, actually. So I have carbon. There's 6 of those, right? And they've got a mass of 12.01. So 12.01 times 6, what are we going to get? We're going to get 72.06 grams. Then for our hydrogen, we've got 1.01 times 12. That's going to give us 12.12 grams. And then we've got our oxygen, which has a mass of 16 times the 6 that are there, and that's going to give us 96. Okay, we add all those together, and we get 180.18 grams per mole. So I know that I have 180.18 grams of C6H12O6 for every 1 mole of C6H12O6. All right, now I'm going to convert from moles of C6H12O6 into moles of carbon. So how do I do that? Well, we're going to use our mole to mole ratio. So for every 1 glucose, I have 6 moles of carbon. Okay, again, I can look up here at my formula. If I've got 1 glucose molecule here, how many carbon are there? There's going to be 6, right? So my ratio is for every 1 glucose, there is 6 carbon. So 1 mole of glucose is 6 moles of carbon. Okay, so now I've converted into moles of carbon. So now let's take that moles of carbon and let's solve for what we're actually looking for, which is atoms. So we're going to go from moles of carbon into atoms of carbon. How do we do that? Well, we learned last class that 1 mole of carbon equals 6.02 times 10 to the 23rd atoms. All right, so now I've got atoms of carbon. And so now what I'm going to do is solve my problem. So I'm going to take all this and plug it into my calculator. And we'll do 16 times 1 times 6 times 6.02 times 10 to the 23rd divided by 180.18 divided by 1, and we will get 3.21 times 10 to the 23rd atoms of carbon. And then this would be our answer. Okay? All right. So based off of that, what I want y'all to do is give this next one a shot. All right? So go ahead and try to do this next one. And then what we're going to do is we're going to go over it like we normally would do. All right? So pause your video, try this one, and then we'll talk about it. All right, so the first thing you should have done was actually solve for what is the formula for aluminum sulfite. What you should have got for that is Al2SO3 3. And so that is what I did right here. Okay, so Al2SO3 3. Now what we're going to do is we're going to convert that 4.55 times 10 to the 23rd atoms of aluminum into aluminum sulfite. All right. And so how we do that, first off, remember, when in doubt, moles it out, right? So if you're unsure what to do, always convert from what you're in into moles, and then you can solve for everything else from moles, right? So right here, I have 4.55 times 10 to the 23rd atoms of aluminum, and we're going to convert atoms of aluminum into moles of aluminum using our Avogadro's number. So we know that for every 1 mole of aluminum, we have 6.02 times 10 to the 23rd atoms of aluminum. Well, now we're in moles of aluminum here, but it's not what we're looking for. We're trying to solve for aluminum sulfite. So we'll drop that low. We're canceling it out. And we're going to go from moles of aluminum into moles of aluminum sulfite. So moles of aluminum, there are 2 aluminum for every 1 aluminum sulfite. So it is a 1-to-2 ratio. That would be our mole to mole ratio. Now I'm in aluminum sulfite, so then I would convert that aluminum sulfite, the moles of that, into grams using our molar mass. And I found my molar mass to be 294.14 grams per mole. I did that from what is right here. So my aluminum had a mass of 26.98. There were 2 of them, so we multiplied by 2. We got 53.96. Sulfur has a mass of 32.06 times 3 equals 96.18, and then oxygen is 16 times 9, which is 144. Add those all together, we get 294.14. Then we take all our work, because the mass of aluminum sulfite was what I was looking for, so I'm going to multiply by the top and divide by the bottom. 4.55 times 10 to the 23rd times 1 times 1 times 294.14 divided by 6.02 times 10 to the 23rd divided by 2 divided by 1. And when I do that, plug it into my calculator, I should end up with 111 grams of aluminum sulfite. Okay? All right. So I want y'all to go ahead and solve this next problem here. It is a little bit trickier than the next one, but I do want you to go ahead and solve it. And then we are going to go over it as well. All right, so pause your video, solve the problem, we'll go over it. All right, so y'all should have worked through this problem, and what you should have found is that your final answer was 2.80 times 10 to the 25th atoms of nitrogen. So how did we get there? First thing we did was we found our formula for ammonium nitride. So ammonium is NH4, it's a polyatomic ion with a +1 charge. Nitrogen, or nitride, is N, it's got a -3 charge. We swap, drop, reduce, we get NH4, 3N, and that would be our formula there. So then we're going to move on and solve our problem. So we have 45.8 grams of NH4, 3N, ammonium nitride, and we're going to convert from grams into moles. We do that using our molar mass. I solve for molar mass here. So I have a nitrogen. It's got a mass of 14.01. There are 4 of those nitrogens there. So we multiplied it by 4. We got 56.04. Then I've got hydrogen. It's got a mass of 1.01 times the 12 hydrogen that are present, which will give us 12.12. Add those together, we get our molar mass of 68.16 grams per mole. Now I use that to convert from grams into moles, because that's your molar mass, is your grams per mole, your mass per mole. Then I'm in moles of ammonium nitride. I convert from moles of ammonium nitride into moles of nitrogen using my mole to mole ratio. For every 1 ammonium nitride, I have 4 nitrogen. All right. Then I convert from moles of nitrogen into atoms of nitrogen using Avogadro's number, 6.02 times 10 to the 23rd. Atoms is what I'm looking for, so I can go ahead and solve. 45.8 times 1 times 4 times 6.02 times 10 to the 23rd divided by 68.16 times 1 times 1, and we will get 2.80 times 10 to the 25th atoms of nitrogen. All right. Now let's go ahead and move on to the next question. So the next question says, determine the number of sulfate ions in sodium sulfate. Now, this one's a little bit different because we're not solving for an element, we're solving for a specific ion that's here, so a polyatomic ion. Sulfate, remember, is SO4 with a -2 charge. So we're solving for how many ions there are of this substance. Then I need to write my formula here. So I've got sodium sulfate, Na2SO4. So there is my formula. So they want to know how many sulfate ions I would have. Well, in how much, right? Well, if they don't tell you how much you have, then you can just assume you've got 1 mole of that substance. So I've got 1 mole of sodium sulfate, Na2SO4. And I'm going to convert from moles of sodium sulfate into my sulfate ion. So looking at this, I've got 1 sulfate ion for every 1 sodium sulfate. So my ratio here is a 1-to-1 ratio. Okay? So now I'm in moles of sulfate, but it's not asking for moles of sulfate, it's asking for how many ions I have. So now I'm going to convert from moles of sulfate into ions of sulfate. I'm going to do that using Avogadro's number. Remember, Avogadro's number can be counted as anything, right? So for every 1 of this, I have 6.02 times 10 to the 23rd. Then I would solve, because I'm solving for ions of sodium, or ions of the sulfate. Multiply 1 times 6.02 times 10 to the 23rd, divided by 1, divided by 1. Our answer is going to be 6.02 times 10 to the 23rd ions of sulfate. So this would be my answer here. Okay? All right. So very last one. I'm going to leave that last one for y'all to do as practice. Y'all should be able to look at the key and see your answer there. But that would be a good place to do one more practice problem before you are done with the notes. All right. Otherwise, we are done with this set of notes. So let me know if y'all need anything. Otherwise, y'all have a great rest of the day. Bye, y'all.